All right, good afternoon, everybody, wherever you are in South Africa or the world. Good afternoon from a very chilly, windy, overcast Gauteng. Welcome to our third webinar in the Talking Timber series. The promotion of timber in the built environment is not only an environmental imperative thanks to its renewability and carbon storage potential, but timber also presents an opportunity for economic growth through timber farming, processing and localization, along with social upliftment that comes with economic growth. Of course, timber is a natural product and thus does not come without its challenges. And that is why we are here today, to discuss the treatment and preservation of engineered wood in the South African environment. A big thank you to Breedt and the South African Wood Preservers Association for sponsoring this webinar, and also to the DTIC and the University of Stellenbosch for always being such keen participants. We are also excited to have some industry experts share some knowledge and insight with you, and it's good to see some of you returning to our webinars and some new names too. The session is being recorded. We have switched back to the Teams platform for our webinar. If you attended the last one, again, apologies for the technical difficulties we all experienced. I'm sure many of you are familiar with the functionality. There is a Q&A section, so we encourage you to pose your questions during the session. And of course, we will do our utmost to discuss them in the Q&A at the end of, towards the end of the session. Otherwise, we will answer them in the chat section. I would like to introduce all the speakers and then they'll hand over to one another during the session. Breedt began his career as a high school teacher before working with the South African Bureau of Standards for more than a decade. He has been the executive director of the South African Wood Preservers Association, or SOPA, since 2009, and a member of the International Research Group on Wood Protection since 2010. Bruce will talk to wood preservation in South Africa, the regulations, current practices, as well as challenges, possibilities for engineered wood products such as CLT. Our second speaker is Willie Conradie, who is representing Timberlife. Willie has worked in wood science research for much of his career, both at the South African Forestry Research Institute and the CSIR. He is the co-owner of Timberlife and the co-inventor of 5 international and 2 local patents. Willie is also a member of the International Research Group on Wood Protection, as well as SOPA, and he has been a member of the South African Bureau of Standards Technical Committees since 1981. Willie will share with us whether the treatment of CLT with surface-applied supplemental wood preservatives is a viable option. Professor Brand Wessels has a PhD in wood science from Stellenbosch University and has worked for the CSIR and as a researcher before returning to the university as a lecturer. In the past 10 years, he has worked closely with the South African sawmilling industry in several research fields, including structural timber quality, saw log plantation management regimes, and engineered wood products. Brandt will share a research overview on the treatment options for South African CLT. And then delivering our closing remarks near the end is Tafadzwa Nyazunda. I'm sure you know her very well from previous webinars, and she is the Director of Forest-Based Industries in the Agro-Processing and Forest-Based Industries Unit of the Department of Trade, Industry and Competition. And if you don't know by now, my name is Samantha Charles, and I'll be helping facilitate the session. So let's get started. I will hand over to Bruce. Bruce, just to unmute yourself quickly.
Yeah, sorry, I'm trying to load the presentation and it's just flickering on my side. So let's just try again.
Let me just unshare my side. There we go. That could be your issue here. There we go.
It's like it's opening now. Thank you very much. So also thank you for the introduction. As soon as the presentation shows, I will start. Good. Can you see it now?
We're all good. Thank you.
Okay, so not to waste any time, let's move right to the purpose of the presentation. Like Samantha alluded to in the introduction, is to present what the building regulations say and actually mean. You'll see what I mean later on by that. To summarize the current available and allowed processes and preservatives that is used in South Africa, and then also to list the challenges when large-scale mass timber products such as CLT need to be preservative treated, which I think many of you already understand and know of. So when we look at the building regulations and specific regulation 13 that deals with, A13 deals with materials, and A13(1)B says all timber used in the erection of a building shall be treated against termite and wood borer attack and fungal decay. And this must be done in accordance with SANS 10005, which is quite important. And then it must also bear a South African accredited, SANAS accredited certification body's mark. Now, when we look at the term all timber, it can be very misleading. And we've actually found some problems on this in the past from engineers and architects saying, but they want to treat certain timbers, but they can't treat it or nobody wants to treat it. And so this term can be misleading. It is misinterpreted, as not all timbers are treatable, nor is it necessary to treat. And I can just mention that we are in the process of trying to amend either the regulation or the application of the regulation to give more detail on this. Then we get to the when, where, and why. When do we treat, where do we treat, and why do we treat? When we look at that, we'll see that it's mainly the threat of degradation to wood when used in certain areas or condition that will determine if treatment is required or not. The second point is the characteristic of the wood. Is the wood, does it have a natural durability or not? And is it treatable? And that will also dictate whether treatment is possible or not. So back to 13(1)B, and it refers to SANS 10005 and 10005, which is something that you have to read together with the regulation, specifies, amongst other things, the approved preservatives and the processes to be used. And it also, more importantly, in clause 12, and in direct respect or relation to, again, A13(1)B, it talks to the use of treated timber in specific demarcated areas in South Africa. When we look at clause 12, it says to qualify as being adequate for its purpose, structural timber of the two main species used in a permanent building in the areas given in 12.2 and 12.3 shall be treated in accordance with 12.4. Now, 12.2 speaks to softwood species, which is your pines, spruces, firs, etc. And here it says that sawn timber, planed and profiled, poles or logs, round or partly round, of softwood species shall be treated in accordance with 12.4 when used in the following municipal areas or towns in South Africa. And then it lists the names, which I'm not going to show now. It also refers to Annex D. There's another requirement in there that's got more to do with the use of load-bearing timber or bearers in decking in the inland areas. That requirement is merely brought in later on because we found that a lot of decks were built in the inland areas, not using treated timber as the bearers, and then you get a moisture trap and you find rot between the actual treated decking planks and the poles, which was not something that we wanted. So that was brought in just as a point of interest. This is the maps, which is included in SANS 10005. There are actually 4 maps: Northern Cape, the Western Cape, the Eastern Cape, and KZN. These maps are also found in 10400 Part L, I think, and it will also be in the revised SANS 10082 on timber frame buildings. It might even be in some other documents as well that I can't think of at this moment. So when we look at the softwood species and the coastal regions, which you've now seen, what are the main concerns? Why is the treatment so important there? And the first one, as you can see on the photo, is Hylotropis violus. It's also known as the European house borer. So you can see the adult beetle, it's quite big. They range between 16 to about 23 millimeters, female to male, and the grubs are quite large. So they can do some extensive damage when there's a couple of them inside a piece of wood. These insects attacked, and they are borer beetles, attacked most softwood species. That is your pines, your spruces, and your firs. They are also mostly active between Port Elizabeth and Cape Town. And the second reason is Cryptotermes brevis. As you can see in the photo, these are termites. They're not borer beetles. Very aggressive little boys. They're called the West Indian drywood termite, the common name. It prefers softwoods, but will attack all non-termite resistant timbers. So you also find in the areas where they're active that door frames, doors, flooring, etc. also gets attacked. Unlike subterraneans, they infest and colonize the wood under attack. So they don't live in the ground, they live in the wood. They fly in, they infest, and they destroy and then move on. They are active in the warmer parts of the coastal areas between PE up to Richards Bay, but very predominant and mostly found in the Durban and surrounding areas. Then we go to 12.3, the broadleaf, the hardwood species. SANS 1005 says that all sawn timber, plain timber, poles or logs of the hardwood species shall be treated when used within the borders of South Africa. And then it also lists products that you can exclude if insufficient sapwood is available to obtain the retention as required. And those products listed there will be mostly sawn machine products where after it's cut from the main part of the tree or log, it is timber that contains hardwood and not sapwood. And you will also see then when we look at the next photo, this is the main culprit that attacks hardwoods, Lictus bruneus. As you can see from the little photo on the left hand side on the bottom, it's not a big beetle. They're similar to maize beetles, very small. Their grubs are small, but when there's quite a lot of them, they can, over time, also cause a lot of damage. They are called powder post beetles, as a common name. They attack only the sapwood of hardwood species, and that's why we will exclude certain products, because if there's no sapwood, there is no threat from Lictus. They only eat sapwood, which is high in starch and sugars. It has a very wide distribution and found over most of Africa. There's another one that's called Lictus africana, I think, if I'm correct. Very similar, does the same thing. These Lictus borers are actually found in many parts of the world. Then we go to SANS 1005 and the processes and the preservatives that are specified. 1005 only specifies the primary impregnation processes and wood preservatives. So these are industrial processes whereby the wood preservatives that are registered and approved for that purpose impregnated in some way or another into the wood. And the first process that's mainly used in South Africa is the high pressure process. There we have two, the full cell process. From the name, it tells you that once the treatment is done, the cell cavity of the wood is filled with chemical. That's where the term full cell comes from. Class W preservatives, which are waterborne preservatives, such as CCA, copper azole, ACQs, are treated pine or used to treat pine and eucalyptus sawn, as well as round timber poles. The full cell process is also used for class C, which are coal tar preservatives, creosote, to treat eucalyptus poles. The full cell process and those preservatives are then used to treat from hazard class H2 to H5. H6, as you know, is a dual treatment of both class W preservative, CCA, and creosote. Then another high pressure process that is used in South Africa is the empty cell process. This process is only used for the treatment of pine poles using coal tar-based creosote preservative, H3 to H5. We don't list H2, although the standard will have it. We don't mention it because you will not use creosote normally in an H2 environment because of the strong aromatic smell. Then we have the low pressure process and the double vacuum process. They are both applied for organic type preservatives, your light organic solvent preservatives. The solvent is the carrier. The only one currently available in use in South Africa in the trademark is the trade name is given there, Vaxilazure. It's azole permethrin based. It's only used for H2 purposes. The hot and cold open tank process, very old process for coal tar-based preservatives as creosote, H3 to H5. And then lastly, we also have a dip diffusion or pressure diffusion process, which is used for class W, which is waterborne borates only to H2. SANS 1005 does not specify secondary surface applied methods, preservatives, and therefore those methods are not compliant to 1005 requirements. And when we go to the challenges that we have when treating a product such as CLT, the treatment of CLT with conventional methods are widely regarded. And when I say widely, it's internationally. I've just been to the IRG meeting in Slovenia, and this discussion has come up a lot of times. To treat large-scale dimension timber with conventional methods, it's impractical, it's not viable, it's very costly. And probably one of the reasons why most CLT in the world is not treated. CLT structures are project specific, so it means they are prefabricated panels. They vary in size and shapes, and that makes it very difficult to plan ahead or have a lot of them in the same size that will fit into a treatment plant. Every project is different. CLT panel, the dimensions are such that it doesn't fit in conventional treatment vessels. In the pre-assembly, so before you make the CLT, before assembly, whether the treatment of those boards is something that can be done using conventional methods, yes, it's possible, but these have their own specific drawbacks, which we'll touch on now. When you use class W preservatives, waterborne preservatives, it requires redrying after the treatment. And that then leads to uneven surfaces on the boards, which requires machining, planing, and that then causes the production of contaminated waste. Now, CCA waste requires specialized and costly disposal. It cannot be burned, and it may not be used for animal bedding or mulch. So that's one of the big problems in using CCA as a pre-treatment. Class O preservative is your organic solvent preservatives. They in turn do not require redrying, and the timber remains dimensionally stable, so there's no uneven surfaces, etc. But it's a solvent carrier, and it can affect the glueability. The minimum retention required by the standard is easily achieved when using the vacuum process only. Mainly softwoods, they penetrate easily, they absorb quickly, and this always or mostly results in that your preservative penetration and distribution being limited, meaning it's not very deep and it's not distributed over the full treatable area. Planing to prepare surface for glueability will then remove a preservative layer, and in most cases or some cases it exposes untreated inner areas of the boards, and we have actually experienced that in South Africa. People using this process and CLT treated this way. A deeper penetration and distribution can be achieved by obtaining higher retentions, but this comes at a high cost. The more chemical you put in, the higher the cost. Solvent-based chemicals are not cheap. Then the question is asked, is it necessary to achieve full cross-sectional penetration on timber? Whether it doesn't matter what preservative is used. So if a CLT panel is used in a protected and dry environment, interior, where by proper design you ensure that there's a very low moisture exposure, then it's highly likely that you don't even have to treat it. But you have to ensure the design is such. If CLT is going to be in any use where there's a high probability of a high exposure to moisture, then you will have to ensure treatment, preservative treatment, to prevent fungal decay. If your only concern or your biggest concern, which is in the coastal areas, mainly when softwood CLT will be used or is used, if your main concern is attack and infestation by wood destroying insect, and you have to prevent that, then treatment is necessary. And the question again, is it necessary to achieve full cross-sectional penetration? And I can only mention from discussions with experts in Australia, people from Europe, when I was at IRG now, that a lot of the work currently being done on CLT treatment outside of your conventional methods is based on surface type treatments, dip treatments, roller applied, spray applied, etc., and preservatives, giving mainly an envelope. And there is a strong belief that that type of treatment can work where you have only a insect infestation and attack risk. So that basically wraps up my part of the presentation, dealing with the current regulations, the standards in South Africa, and the challenges. Thank you.
Thank you, Bruce. Over to you, Willie.
Thank you very much. Let me just share my presentation.
Bruce, just unshare yours on your side, and then it'll be easier for Willie to take his to screen.
Okay, my presentation is on my screen. Can everybody else see it?
You can see it, thank you. Well, I can see it at least. Thank you, Willie.
Thank you very much, Sam. Good afternoon to everyone. The topic of my presentation is about the treatment of cross-laminated timber with surface-applied supplemental wood preservatives. And obviously the question is it a viable option? Firstly, why is preservative treatment of CLT necessary in South Africa? In many countries, as Bruce has mentioned, it is assumed that design for durability, that means the exclusion of moisture, is sufficient to prevent fungal decay, and that preservative treatment of CLT is therefore not necessary. However, even when used under interior conditions, fully protected from the weather and any moisture ingress that may cause fungal decay, untreated timber can still be attacked by wood-destroying insects in certain countries, such as South Africa. In the coastal regions of South Africa, softwoods are attacked by the European house borer. In the more subtropical regions of South Africa along the coast, timber can be attacked by the drywood termite. And throughout South Africa, the sapwood of eucalyptus timbers can be attacked by the powder post beetle. Why is conventional preservative impregnation of CLT a problem? Firstly, because of the large dimensions of CLT panels, it is seldom possible to treat it in conventional impregnation plants. Treatment before assembly is possible. However, it's very costly and time-consuming, and it also results in certain cases, it requires pre-assembly machining that removes some of the treated timber and obviously results in treated wood waste that needs to be disposed of. Interesting question is, can surface applied treatment with currently approved wood preservatives be done? The answer is no, because the relevant SANS standards do not include surface applied treatment as an approved method of application. Also, none of the wood preservatives currently listed in SANS 10005 and SANS 1288 have been registered for surface applied treatment of timber. It can therefore not be certified for compliance through SANS accredited certification processes. Is surface applied treatment of CLT provided for elsewhere in the world? Unfortunately, there's not a lot of information on this. However, in the New Zealand specification, NZ 3602 of 2003, under subclause 104.5, it is stipulated that when laminated timber is installed in an interior position, in a building fully protected from the weather. It is exempted from the treatment requirements of 104.4.1, and the completely dimensioned and finished beam may have a surface coating of an approved insecticide fungicide. The NZS 3602 standard is currently under revision. A new section 4 has been added, and this now includes requirements for large format timber elements to achieve a 50-year durability, and includes CLT, glulam, and LVL. It further specifies that, and I quote, when a glulam or CLT member is installed in an interior wall or floor within a building and not in a wet area and fully protected from the weather, the completely dimensioned and finished member shall have a supplementary surface treatment applied to all surfaces. The surface treatment shall be a boron in glycol formulation, which contains at least 20% boric acid equivalent, and shall be factory applied by brush or roller as 2 coats to all surfaces. How can surface applied treatment of CLT be certified for acceptance and compliance in South Africa? One possible route that we have discussed is to enable compliance certification of suitable surface applied preservative treatments by registered pest control operators. The following conditions, however, will need to be carefully considered. Only for specific and specified mass timber products that are difficult to treat otherwise, such as CLT, and only allowed for low-risk interior application that is fully protected from the weather and against any ingress of moisture. Only for preservatives that have been formulated, registered, and approved for secondary surface applied supplemental treatment shall be used. Only completely dimensioned and finished mass timber products shall be treated in this way. Treatment shall be done at the CLT manufacturing facility by a pest control officer registered in terms of Section 3(2)(c) of Act 36 of 1947, and strictly in accordance with the wood preservative manufacturer's directions for use. The treated timber shall be marked as surface applied treatment, for example, SAT, with the pest control operator's name and registration number. On completion of treatment, the pest control operator shall issue a certificate of compliance containing all relevant information. All surfaces that are exposed during installation as a result of machining or damage shall be recoated with the same preservative solution. Noteworthy is that a proposal regarding the above has been submitted by SOPA to the NRCS Technical Advisor, National Building Regulations, for consideration of CL treatment of surface applied wood preservatives as an alternative approval option for building control officers where other SANS 10005 approved treatments cannot be complied with in terms of Regulation A13(1)(b). And lastly, what is the way forward? The good news, there are wood preservatives available in South Africa that have been registered with DAL-RRD for surface applied treatment. The challenge is to obtain acceptance and approval for treatment of CLT with surface applied supplemental wood preservatives in South Africa. And that concludes my presentation. Thank you.
Thank you, Willie. Thank you very much. We will hand over to Breedt. It's your turn. Thank you. And just encourage you to put your questions and answers, or questions at least, into the Q&A box if you've got any. Thank you.
Good day, everyone. Sam, can you hear me and can you see my slides?
All good, Brant, all good.
Okay, so I will give a short overview of treatment options for South African CLT. I will give a research overview of research that was done here at our department, mainly by two postgrad students of mine, a PhD student, Femi Aladi, and an MSc student, Kiniso Mbamali. I can't seem to get the slide to move. Oh, there it goes. Good. So as Willie and Bruce already talked about this, the problem is that CLT panels are too large to fit into preservative treatment vessels. So on this picture on the right, you can see the size of a typical CLT panel, and at the bottom you can see the current type of preservative treatment vessels, and it's very clear that we cannot treat CLT panels after manufacturing. And then, of course, you can. The second option is to treat the laminates first before you glue them. I think Willie and Bruce both alluded to some of the difficulties with that process and the risks and so on. But that is exactly where we focused our research of the two students. And that's what I'm going to talk about. So that's the traditional preservation methods that's already been approved through SABS. So the scope of the project was much larger than, or the two projects were much larger than what you see here. But in any case, this is just sort of a very short focused discussion. So we worked on both SA pine, Pinus patula, and on Saligna, as it's known commercially, or Eucalyptus grandis. For the patula, we tested two preservatives, the traditional one in South Africa, often used, CCA, and then we also tested the sodium octoborate tetrahydrate, or DOT, or that's a boron-based preservative. And as adhesive for SA pine, we used polyurethane. So those were the tests on pine. For Saligna, we tested two preservatives, copperazole and also the boron-based one. And there we tested three adhesives, polyurethane, melamine urea formaldehyde, MUF, and phenyl resorcinol formaldehyde, PRF. And after, manufacturing test samples, all of them was tested for shear strength. And for delaminations, those are in all the international standards, the sort of standard method of testing bond quality. I must just say here that we've used the standards for glued laminated timber, and simply because those standards are much better developed than CLT at the moment. These are just two pictures of the two test methods. On the left, you can see a shear strength test, self-explanatory, I think, and on the right, a delamination test. So the delamination test usually consists of manufacturing a block of wood, in this case 5 laminates that you glue together after treatment. And then you have repeated water impregnations and oven drying cycles. Depending on the adhesives, it can be 2 or 3 cycles. And after the final drying cycle, you measure the length of the delaminated bond lines. So those were the tests which we used to evaluate the bond quality after treatment. So quickly to the results. These are let's say the two main results for the Pinus patula, SA pine. So the graph on the right, you can see on that graph on the y-axis, you've got your wood failure percentage, and the x-axis, the shear strength. Now, according to the EN 14080 standard, if your treatment, the mean falls above that solid line that you see in the graph, then it will pass, and if it's below, then it will fail. So above the line, you see for the pine all the different treatments that we had, the CCA preservative treatment, the DOT treatment, different density classes that we had, and also hardwood and sapwood. And you can see that all the the different combinations passed the shear strength and wood failure requirements. So that seems to not be a problem with pine. And then on the right, just a ANOVA graph of total delamination. So on the y-axis, you can see the percentage delamination, and you can see that we had there the 4 or 2 treatment chemicals, and each one at two different concentrations. But you can see that the means vary between about 0.5% delamination to 3.5% delamination. And the maximum limit that's allowed in EN 14080 is 10%. So that's well below, the delamination that's allowed. So clearly what we can see just from these two graphs is that there doesn't seem to be a problem treating pine and then manufacturing CLT with a treated timber. Okay, sorry for this graph. It's quite a busy one, but in any case, so this is the result for Saligna or Eucalyptus grandis. It was a bit more complicated. It was also a different type of experimental setup, but just to you don't need to worry about all the numbers in there. But at the on the top line in the titles, you can see we tested 18 different process runs, so it's different variables in each process. Those include planing, so there was surface planing after treatment or not. Then the different preservatives, the different adhesives, and we also tested different pressure at the when the CLT was manufactured. And then the last 3 columns was just the shear strength, wood failure, and delamination results. So the lines that are in green were those that were acceptable treatment processes according to the EN standard. So for treated CLT. So you can see for probably the biggest difference is that most of the processes that include planing of the surface after treatment gave acceptable results. Then the process run R13 and 14, which is quite interesting, was process runs where there was no surface treatment or no planing after chemical treatment, and those two actually also gave acceptable results. Of course, these are laboratory manufactured samples, so on an industrial scale, one will also have to see if it, if it still complies. But it seems that there are quite a few process routes to treat also Eucalyptus grandis and get acceptable results. And the interesting one for us certainly was that even without surface treatment, some of the routes seems to hold potential. So very short conclusion. Both Pinus patula and Eucalyptus grandis it seems like you can treat it successfully to at least H2 level. That's for indoor use before being assembled and glued into engineered wood products such as CLT. There are, of course, it's as Willie, I think, said, it's a more expensive process. There's problems sometimes with getting rid of waste. So if you can somehow get a process where there's no planing after your chemical treatment, that would be a huge advantage. But it's certainly not as easy and low cost process as the one, a surface treatment, which would be, of course, preferable. I've given you just very short results. If you want to see detailed results, and we tested many other things in those projects, here are 4 papers that's been published this year, which give more details on the research that we've done. Okay, and finally, just acknowledgement of the funders for this study. Thanks.
Thank you very much, Brand. Thank you, Willie, and thank you, Bruce, for your insight. We don't have any Q&A questions in the Q&A section, and I'm worried that some people can't actually see the Q&A section. So, and I know Michael Kloos may have had a, here we go. Questions to Willie. Let me get, here we go, from from Michael. Question to Willie. You mentioned surface treatments that are approved by the Department of Agriculture, Land and Rural Development. Can you give some named examples, Willie? Are you able to answer that for Michael?
Yes, Michael. I think most of the pest control people are aware of two preservatives. The one is called CTX 108, which is a solvent-based product, and it's used extensively for pest control and obviously also for surface treatment of timber for probably now 25 years. Sorry, let me just put one on my camera. Then obviously the later one is the Glybor 300. And that was basically as a request from the pest control people. They wanted a more waterborne, let's call it more environmentally friendly product. And this is very similar to what they call the boracol, what you find overseas. And in my presentation, I mentioned about the glycol borate formulation that's been mentioned in the New Zealand specification. So this will fully comply with that requirement.
Thank you, Willie. Any other questions? Perhaps anybody from the panel, if you've got questions for one of your fellow speakers. I'm sometimes aware. Okay, Brent?
Sam, can I just ask Willie?
Yes.
Willie, at the moment, so if I want to build a house with CLT, is there a legal way for me to use a surface applied treatment at all at the moment? Is there a way to get through past the local authority?
Bron, no, unfortunately, the question is no. We basically got involved with this probability of surface applied treatment when the Nelson Mandela University was looking at it, and I see Emma is here, and she can probably tell you more about it. And we had to try and get around this because it cannot, as I mentioned, it cannot be certified because this type of treatment is not specified in any of the current standards. So that's why we're looking at the alternative method of maybe using the pest control people that are registered with the department as a way of doing it. But yes, to answer your question, plain and simple, no, they are not, and we're working towards that. And that's why SOLPAS also approached the NRCS National Building Regulations in this connection.
Thank you.
Sorry, Bruce, would you like to maybe just add to this?
Willie, yeah, I just wanted to address something that on Michael's question, and perhaps you did mention it now because I was typing an answer to somebody else's question, so I wasn't really listening. But I think it's important to note that those products that are registered by the Department of Agriculture, when they are applied for commercial means you apply them in your daily occupation or job, and also there is a cost involved. It means it's a commercial purpose. It can only be done by registered pest control operators according to that law, and it's something that people must also take note of.
Thank you, Bruce and Willie. I see, Bram, your question was answered in the chat. How well is the SANS 1005 applied by building control officers? And Bruce answered, in the case of coastal regions and for registered building projects, they are applied very well. So thank you for that. I take it that you guys delivered enough information that we don't have that many questions from our participants. So you probably did a very good job. We've got a hand raised from Bram. Bram, you have the ability to unmute and speak, so go ahead.
Yeah, Bruce, I wanted, well, I'm going to address the question to all three. First of all, if I built a CLT house, say in Pretoria, will you have to treat, in your mind, if you don't treat that building at all with any surface treatment and you've got some exterior wood, you are at risk for you are at risk if that building is not treated? Or can you answer that?
Well, if I can start, in the interior region, there's specifically no regulations for the preservative treatment of softwoods, really because these regulations are very much based around the insect threat. So flying insects, such as Hydrotropis and the drywood termite, we don't have here. That cause a lot of damage. The only big concern, which is a major concern in inland areas, is subterranean termites. And the building regulations at present specifies where you are in termite areas, you have to apply a soil poisoning in your foundations. And that's how you control termites. I mean, there's always termite barriers. And yeah, and so for the insect, on the insect side, no, it's not necessary, because if you can control the termites, then subterranean termites, you don't need it. But if you're going to have large panels exposed, I think exposure is more maybe a problem of weathering. Then you will have to apply some kind of surface coating. In general, as I understand internationally, it's not advised to use large exposed panels of CLT on buildings because of the maintenance problems, especially if it's going to be mass buildings. It's mainly used for interior walls, floors, etc. So do know if you use it on any area exposed, you will have to protect it using a surface coating. We're not talking preservatives, we're talking something that protects against UV, weathering, etc. A fungal risk, again, if you design it correctly and there's no high moisture ingress, etc., then there's little fungal threat, but that comes into your design. That's how I see it. I don't know if Willie or Brandt wants to say anything else.
No answers from Willie or Brunt, but we do have some more questions for the panel, and maybe Bruce, you could perhaps answer this. Does this, and this is from Joy Crane, does this mean that existing CLT structures and panels installed in South Africa are not legal? If you could answer that, and then we've got another one in the chat that I'll share with you.
Well, unless you've had prior approval by a building control officer to say that you can do it without treatment, then yes, it will be legal. But I also know that some of the CLT, if not all of them, I'm not directly involved, have been manufactured using pre-assembly treated timber. So yes, in those cases, they will be legal. If untreated CLT was used, if the building control officer approves it, or somebody else, like an agreement or so, they must take responsibility if something does go wrong. My view.
Thank you. We've got a question from Richard Miller in George. Which just jumped. I believe that termites cause more damage in Africa compared to elsewhere, especially in Europe. Is this true, and thus cause more concern when looking at European-based research? And if anyone can, Bruce or Willie, could you answer that one?
Well, subterranean termites are a major problem in South Africa, Australia, South America, and in certain parts of America. But in Europe, it's not really a big problem. It's more would decay, obviously, because of the wetter climate. And then they also got some wood borers. But Bruce, I'm not aware of a major termite problem in Europe area. Are you?
Really, yeah, I think when you look at the more Mediterranean areas like Portugal, Spain, and some of those countries, they definitely have subterranean termite problems, even certain parts of France. But yes, we do your more colder northward countries, it's less of a problem. But interestingly, at the recent IRG, there has been mentioned that due to climate change, they are finding subterranean termites in areas where they previously never found them. So it is something that we must also consider due to climate change. Even on our wood borers that we find at the coast, there's no evidence in South Africa that they have actually migrated inland. but it's not something we can just disregard that it might never happen, because we see things changing in other parts of the world. But like you said, Australia, definitely a big thing. America, Hawaii, your more warmer climates, Malaysia, they have huge subterranean termite problems. Yeah.
Thank you. And I think we will make this our last one before I hand over to Tafadzwa. This is from, again, Michael, a general comment to which any of the speakers can respond. To build a legal CLT building in coastal zones, we are forced to pressure treat. We have seen, however, in previous projects in South Africa that machining removes majority, if not all, of the solvent-based treatment. And I think this is something that Willie mentioned. So the reality is that even though the building is legal, one could argue that it is not, in fact, treated in its final state. So we are following the rules, but are we being truly safe? Anyone going to put their hand up for that one?
I think Bruce can probably give a clearer answer on that, but I think he's mentioned specifically that if you don't get deep penetration and you do pre-assembly machining, you can remove some of the treated wood, and it's likely that you might expose some of the untreated wood. In such a case, obviously, you can rectify it with a surface applied treatment afterwards. But yes, if you don't do anything about it and you expose untreated timber, the wood borer can get in.
Michael, I hope that answers your question, but if not, you're welcome to take it offline. Bruce, do you want to add?
I think that is spot on.
It's brand here.
It might not completely comply legally because you've exposed after the treatment, and mainly the standards always say that preservative treatment should preferably be done before any machining is done. In this case, in these cases, it wasn't possible. So you then expose, and then the standards also say then you have to apply a remedial and supplemental preservative to cover any exposed untreated areas.
Grant, you wanted to come in there as well?
Yes, Michael. I think although it was only at the research stage, it's it's clear that you can treat it with also non-solvent-based preservatives. And I'm thinking CCA is perhaps a problem, especially with the waste that you create, after planing the treated timber. But with something like boron, it's less of a problem. So you can perhaps do a pressure treatment boron, which is water-based, and that penetration is definitely, quite a bit deeper than the solvent-based one. So that's an option, but I don't think a lot of sawmills at the moment do that type of treatment. In fact, it's quite, difficult to get places to do that, which is more of a practical problem, but it is possible at least. And then, of course, the other issue is the drying after treatment. So you have to sort of re-dry it again, which is also a bit of a hassle.
Thank you. Bruce, did I see your hand? Did you want to add anything?
Now, Brant actually mentioned about the boron, water-based boron pressure treatment not being available in South Africa at a large scale. There's only a handful of treatment plants, I don't even think it's a full hand, that use boron. So yes, that is the problem. It's availability, but it's possible.
Thank you. Willie,
Sorry, I know we were running out of time. I just want to mention one advantage of boron treatment. It can be done on green timber. That means before you do any kiln drying, you can do, like Bruce mentioned, dip diffusion, and then you do your kiln drying. So you don't have to pre-dry it before treatment, as you have to do with other preservative treatments. So that is an obvious advantage.
Great, thank you very much. With that, I would like to hand over to Tafadzwa just to deliver some closing remarks. Over to you, Tafadzwa.
Okay, thank you very much. Sam, thank you so much for the brilliant work that you have been doing. And colleagues that have joined on this call, this is the third webinar that we have done. The first one we did on structural engineering of mass timber buildings, and this was held in October 2021. And then the second one was done on the 12th of May 2022, which dealt with engineered wood in the built environment. The two webinars were sponsored by Sawmilling South Africa, and thanks to Roy for that. So today we really dwelt on the treatment and preservation of timber in the built environment, and also of engineered wood. So you can attest with me that we do have a body of knowledge that is out there that will be able to assist us, or that is able to assist us, and also to enable us to implement the mass timber building in South Africa. All this work is happening on the work that the DTIC, in collaboration with the industry as well as human settlement and a number of government entities, has embarked on, to see how do we, or how can we push timber into construction, as well as also do we have enough timber. So all these webinars are being done in order for us to just create the awareness out there, and also to say that yes, it is possible to do this in South Africa, and it can also be a solution to the much needed human settlement in this country. So we just want to say that with that, I think I will take the opportunity to thank our sponsors for this webinar, which was Sawmilling, which was South Africa Wood Preservative Association, Bruce Breedt. Thank you so much. And also to our speakers, once again, Bruce, thank you. Willie Conradie from Timberlife, thank you so much. And Prof. Brandt Vessels from University of Stellenbosch would also want to thank you for continuously supporting this work, as well as sharing the knowledge. And like I always say, that one day we would want to see these mass timber construction sprouting in every corner of South Africa. And definitely, hopefully in our lifetime, we'll be able to see that. And lastly, but not least, would want to thank our audience that have stayed on this call, and also that have joined on the call, and also continue to work with us. There are quite a number of people that I cannot mention by name that have been supporting this cause, and we will continue to work on this. This is part of the Forestry Master Plan, and hence we are actually implementing the master plan as we are doing this. And it's a third of the 6 webinar series that have been planned. So as soon as we have the date for the next webinar, we will be coming to your emails, and we will send you the invitation, and looking forward to your support as usual. I think from me, this is all I have. Thank you, Sam. Over to you. Thanks.
Thank you, Tafadzwa. Thank you so much for your support. It's always good to have the support of the DTIC. And just with that, thank you so much for your support and for joining us. Please keep an eye on your emails. We will be sending out the invitation for the next one, which will be quite hot. We'll be talking about fire. And again, it's a hot topic. We will be recording, obviously this is being recorded, and we will post it to YouTube and onto timber.co.za, and we will send out the relevant links once they are ready. But again, thank you again to Bruce, to Brandt, to Bram, to Willie, to Fatwa, and to everybody who took the time out to join us today. Thank you, and have a good day and stay warm.